Solomon, you can also start the recording on your end if you want. So you can directly, that recording will be directly saved to your machine. Okay. So let's quickly go through what we discussed yesterday. Check the documents. Okay, there it is. Let's open it using Paint. Okay. So yesterday we talked about types of networks, how many types of networks there are, in which we talked about personal area, local area, campus area, metropolitan, wide area, and storage area network. Mainly it depends on the range in which you are working, in which you are creating the network. Okay. So what we will be focusing in CCNA is this one, the local area network, which is generally made private, because in this we are going to use private IP addressing and all that. Okay, so we will not be talking that much about public IP addressing. A little bit will be there, but not that much. Then we talked about characteristics of all these networks: LAN, which is within a city, within a building; metropolitan area, within a city when you are connecting two endpoints. If you are going across borders of cities, states, or countries, that means you are connected using wide area network. Okay. Just a minute. After that, we talked about the ways of communication, in which we had three ways, that is simplex, half duplex, and just hold on a minute. Okay. So, Karam, tell me about types of communications: simplex, duplex, and half duplex and full duplex.
Simplex is a one-way connection, and what was the other one? Simplex and
half duplex and full duplex.
Half duplex is where we can. It's a two-way connection where we can send and receive. And the other one was
full
was it full duplex?
Right. Three were there. First one was simplex, then half duplex, and full duplex.
Yep.
So how will we differentiate in these three? First one, simplex, is one-way communication. Only you will be inputting some data and that's it. Nothing else.
Yep. And the half duplex is a both-sided communication, but it's only possible one at a time. When you so it can be at the same time.
Right.
The communication can be at the same time. And the other one was a full duplex. It can be possible at the same time. the communication can be possible at the same time
Right.
from both ends.
So simplex, in which we are only communicating one way. In half duplex, both side communication is possible, but one at a time. Like if laptop 1 is sending some data to laptop 2, during that time laptop 2 will not be able to send the data to first one if it was half duplex. If it is full duplex, then they can simultaneously send the data to one another. Okay. Then next is a server and a client. So a powerful computer that is providing any type of service can be said as a server. Either you are getting your storing your images there, or movies, or files, or could be anything. And client is a machine by which you are using the services provided by the server. Okay.
Yep.
So depending on the use case, they can be named differently, like web server for website hosting, application server for application hosting, print server for managing printers and all that in a network, file server where you're storing files, mail server for mailing configuration and all those things.
Yep.
Then next we talked about network architecture. So two types of network architecture were there. First one peer-to-peer and
Yep.
another one server client.
And the other one,
So in peer-to-peer, every machine can be server, every machine can be client. Okay. It's not fixed that this particular machine is a server and all the rest are client. In peer-to-peer, any machine can be server. Whereas in server client architecture, only one server is placed and all the rest machines will be clients. So if
Clients.
anybody wants to get the data, they need to go to the server machine. Okay. So these two architectures were there. After that, we were gonna start our network topology. So before jumping to that, Karam, tell me unicasting, multicasting, and broadcasting difference.
Unicasting, I'll tell you from broadcasting, where we can share data with anyone. Like if there is a total number of machines, like if it is a total number of machines in one room, and you want to share data with, if you share data with like both of them, that's broadcasting. And if you're choosing to share with only one, that's multicasting. And
can you repeat the last one?
The unicasting.
The broadcasting was sending the data to
everyone, sharing with everyone.
Right. Then multicasting.
When you choose to when you're sending multiple people only, not all. Like when you're choosing to, if there's two machines, then you're choosing one. That's a multicasting.
Okay. And unicasting.
The unicasting was when you're sending a particular data to one machine.
Like if we have, let's say, 10 people in a room. So 10 people are there, and let's say I'm just taking the session in that room. Okay. So on this end, Karam is sitting, on this end, Solomon is sitting, and here I'm standing. So if I'm delivering a session in that room, so that session, the content of that session will be delivered to everyone present in the room, correct?
Yep.
So that will be
That's a
broadcasting, right? Because we are not selecting any particular person to send the data. We are just sending the data to all of the persons or systems in the network who are present right now. Okay.
Yep.
Then that was the broadcasting. In case of multicasting, let's say I'm delivering something, I'm delivering some content, but I'm only providing the content to the people on this side. Okay. I'm not providing any content to the Karam side, only providing the content to Solomon side. That will be multicasting. Like out of all the systems, we are only providing the content to some of them. Or it could be like this. I'm only providing the content to Karam and Solomon, nobody else.
Yep.
Okay. As for unicasting, I'm providing the content one by one. Like I'm calling Karam to me and then said something to him. Then I'm called Solomon and said something to him. It could be the same content. It could be any different content. It's up to me.
Yep.
That will be our unicasting. Okay. So today we are gonna start our network topologies. So what is a topology?
It's an arrangement of elements to communicate and like.
We can say a
It's a structure of elements for communication of network.
So how we are gonna create how we are gonna connect those systems so they can communicate with each other. So we are gonna make a structure of that particular network, a design you can say. So each design have its own pros and cons. Before going on that, we have two types of topologies, logical and physical. In logical, we are gonna deal with protocols and all those things. We are gonna configure protocols on routers. We are gonna use advanced feature of switches and all those. Whereas in physical topologies, that is the physical structure of the network, how you are placing how you are connecting those particular devices. If you have 10 devices, you can either use a switch to connect them, or you might be using a hub to connect them, or you are using a single cable and putting some connectors between them. Okay.
Yep.
So let's start the topologies for today. And physical topologies. So now we have 8 types of topologies here. Okay. From single node, then bus, star, ring, dual ring, mesh, and hybrid. Okay.
Yep.
Just a minute. Okay. So let's take the first one. Let's start from here. So first is our single node topology, in which we are gonna connect multiple devices, but there will only be a single server that is gonna manage all those devices. Okay. So let's say I put a PC here with a CPU and every other components here. So we have a monitor, a keyboard, and everything.
Yep.
And here we are gonna put our node. This will be a server. monitor. CPU and okay. So now I want to connect multiple devices here. From this CPU, I'm gonna connect this particular node. Okay. Then if I want to connect some more nodes, I'm gonna use the same cable to connect multiple nodes here. We are just gonna put some connectors like one here, one node, and let's say one more. So I've used 3 connectors here, and in all those 3 connectors, I can connect my different node. So we have 3 nodes here, node 1, node 2, and node 3. But these nodes are called dumb devices. And why is that? Because they don't have a CPU of their own.
Yep.
Everything is being managed by this particular server. Okay.
Yep.
So all these are dumb devices. They have the rest of the components which are needed except the CPU. So if we talk about the costing, this single node topology is the least expensive out of all of these. Okay.
Yep.
Let me add here. So only the server have a CPU. Clients don't have a CPU of their own. And clients are called dumb devices. Okay. And we are going to use connectors to connect all these nodes which we want to connect it to the server. So what is the major advantage or disadvantage of this particular network topology? One advantage is that it is the least expensive. What about disadvantage?
I thought you said it's the most expensive, the single node topology.
Least expensive.
Okay.
If the server goes down, that means
right. If the server is down, the whole connection goes down. Okay. Because every node is using the compute power from the server, and if that's down, everything's gone.
Yep.
Other than that, we can say easy to install. We just need to purchase a connector and the rest of the components and connect it. We don't have to worry about the server because that is already there. Another disadvantage could be as we increase the node, as we increase
the bandwidth,
right, increase the number of clients, the performance of the network goes down. Decreases. And it is also easy to monitor what the other person is doing. Okay, like if we have internet cafes, in that If you want to connect all the systems using a single server, and first of all, you need to purchase a server, purchase a CPU that is of high configuration. Once you have done that, you just need to connect these clients, and whatever your user is doing there, you can monitor everything. Okay, if you want.
Yeah.
I think example of this single node is those cafe. They just connect the cafe, internet cafe.
Right.
They just provide this stuff like this.
So in that, the provider can check what the person is doing if he wants.
Exactly.
So it is easy to install. It is, you can say, does not cost that much compared to other, because you don't have to put CPUs. Mainly, that's the main thing that costs money. Other than that, the rest components will not be that expensive. Okay. So this is the first, that is single node topology. Then let's see it here. Second one is a bus topology. So what image comes to your mind whenever you heard the word bus? Which thing comes to your mind? In general, like if somebody says, if a the child says something, what is the bus? What will you tell him?
Maybe like from the word bus, literally, like you're gonna have like a single line transporting multiple systems, something like that. Like when you're in the public bus, the bus just everybody just enter the bus.
Right.
So in this kind of scenario, you have just maybe like a single line and connecting multiple systems.
Okay. So whenever someone says that what is a bus, so the first thing that comes to our mind is the vehicle that we have, and like this we have that seats in those. Okay, so at the front, let's say here's the gate. So if you want to go to the last seat, you will be going using the gate, right? Or you will directly climb through the window. Okay. So mainly, if somebody wants to go there, he needs to go through this path. Okay. If he wants to go to last seat or the third one or whichever seat he wants to go. So just like that, if we use the same concept in our network part, a single cable is there. Okay. On that cable, we are going to use our connectors. 1, 2, 3, and 4. And on those connectors, we are going to connect our nodes. So PC1, then 2, 3, and 4. Connect it here. Okay. Let's name it 1, 2, 3, 4. So now we have 4 devices in our network. Okay, and if I want to send some data from any of the devices to any, like if I want to send data from the first one to the fourth one. Okay. So the data will be going through this cable only. If the second device wants to send the data to any of the device, that data will also go through this cable. If third wants to send, that too will be using the same thing. Okay. So our main means of transport of data will be this particular cable, and this is called our backbone of the network. Okay.
Yeah.
Or you can also say it trunk. So all the data will be delivered via the trunk on which the nodes are connected, on which the nodes are attached. Okay. And if I don't want to increase, if I don't want to add the systems after there, so I can just break my network here. In case if I want to add more systems later on, then I can again add a connector and add the devices that I want. Okay.
Yep.
Just okay. In 10 minutes, we are gonna, the meeting will end and we will be starting the meeting again. Okay.
Yep.
Okay. So
I can't imagine how data will be very slow in this network.
how data?
I mean, I can't imagine how communication will be very slow. Communication of data in this network will be very, very slow.
And first of all, let's say the most important point of bus topology is that the data will always be broadcasted.
Broadcast.
Okay. So if you want to create a network in which you want to send the same type of data to everyone, then you can use this. Okay. If the network is small. Other than that, if you want to add some devices, that is easy to, you can say, expand the network. Okay. It is easy to expand the network. But one of the most, you can say, disadvantage thing in this is that if the backbone is broken, you will not be able to send the data to anyone.
Yep.
If the backbone is broken, backbone, or let's say trunk is broken, the whole connection goes down. Okay. Other than that, it only transmits the data in one direction. At one point, transmits the data only in one direction. Why is that? Because if you send some data from first machine to the third one, or let's say first to third and fourth to second. Okay. I want to send some data from the first machine to the third machine, as well as I want to send some data from the fourth machine to the second machine. So there is a possibility of collision here, because if we go on a one-way road and you are taking your vehicle from here, you are on the correct path. But if someone comes from the opposite side and he's in the wrong, but he's not taking his vehicle back, then neither he can go anywhere nor you can go anywhere. Okay.
Yep.
And no acknowledgement will be provided once the data has been delivered or not. No acknowledgement on data delivery. Okay. Other than that, if the connector is also broken, the network will go down. Like if the connector of the second machine is broken, that is
Yeah.
using the same cable. If the connection is the connector is broken, the connection for other devices will also go down, because first machine will not be able to send the data to third one or to any other machine. Okay. If the connector of any node is down, whole connection goes down. Other than that, the cables have limited length. Okay, you can connect most devices on a single cable, but the length of that cable will be limited.
Yep.
Length of the cable is limited, but if we check the cost, it is cost effective.
Yep.
Cost effective.
So what type of cable is used in this connection? What type of cable is being used in?
What about?
What type of cable is being used?
What type of cables will be
What
used?
type of, yes,
Coaxial cables. Or if you
coaxial.
want, right, RJ45 connector you want to use, then you can use those. So depending on the network card of each computer, it might differ. If you are using, if you want to use that twisted pair, that too is also possible.
Okay.
Okay, cost effective, does broadcasting, connectors down, backbone. Yeah, mostly these are the advantages, and yeah, you can also add it here that used in a smaller networks. Okay. So this is our bus topology. After that, next one we are gonna talk about is star topology. So the broadcasting point in bus topology could either be an advantage or disadvantage depending on the situation.
Yep.
If you want to deliver data to everyone, then in that case it is advantageous. But if you don't want to deliver it, then it will be disadvantageous.
Yep.
Then next is our star topology. So in a star topology, let's again create multiple nodes. This one is our node 1, and let's copy it. And let's create a star. So now we have 5 nodes here.
Yep.
1, 2, 3, 4, and 5. And now this time we are going to use a hub by which we are going to connect all these devices. So a hub will be connected. Let's connect these devices. 1, 2, 3.
Can we use anything else apart from hub to connect all the different clients?
Just a sec. So this hub device can either be a normal hub that we used before. Right now we don't use hub that much, or it could be a switch or router.
Or router as well?
Hub is just like where all the devices are being connected, a centralized device, you can say.
Yep.
Centralized device. So all the nodes will be connected using a centralized device. So now the performance of the network will depend on the device that you are using. All the nodes will have a dedicated connection